Okay, let's demonstrate the rigid pendulum tutorial example. This is our goal, and what we're showing is a model that has a bit more complexity than what we'll arrive at, but demonstrate and simulate exactly the same system. What this shows is a pendulum and a mass as two separate nodes with a mass of 1, a distance between the pendulum and its grounded point of 0.5, and it'll start with an initial omega of 0.2 radians per second. And we're showing here two reference frames. The mass is being shown as having a 0 velocity and 0 angular velocity. So that's really more in the global reference frame in terms of its motion. So we won't need that. On the pendulum, we're showing it starts at that 0.2. We will need that, and we'll show how that's done. And then so we have the two nodes, and there really won't be a need for additional nodes. We'll only use those two. And then we'll have the the and the body and the joint. So it won't be nearly as complex, but it will come up with the same motion. So let's start over here. We've created a new scene, and let's pull this over here for right now. And we'll very quickly go through this, but hopefully at the same time this will be illustrative. So to create a new object, we'll do Shift A, and from Shift A, then we'll just choose a cube. We'll go ahead and give this cube a name. We'll call this a clamp. Okay, and then we'll create the element. The element will be a joint, a clamp. And so there we are. Now we'll rotate this because we know we'll need to. This will be our reference frame. So we're going to click R to rotate, press the Shift key so it'll click, and you'll see down actually the Control key. You'll see actually, if I can, well, if you see, let me escape this. If you look here, as I'm moving it, you'll see every 5 degrees shown. So I'm going to, again, press R and then hold the Control key, and you'll see rotate 15, 20, 25, 30. All right, so we'll take it up through 90 degrees and then press the left mouse button, and we're locked in there at 90 degrees. So that's our clamp. Now Shift A to create another body. We'll make it a cube. This one, we'll call it a revolute hinge, R-E-V-O-L-U-T-E H-I-N-G-E. Okay, that's just more for, it's not necessary. We're doing this just to help us understand what these nodes are. So from here, what we'll do is we'll first click our clamp, and then Shift and click our revolute hinge and add a joint and make this a revolute hinge. Good, so we're there. Now we notice it's rotating in the wrong direction. So we'll again click this, press the letter R, hold the Control key, rotate through 90 degrees, click the left mouse button, and now we're locked in. So next what we'll do is we're going to duplicate this. So we click the object that we want to duplicate and press duplicate. All right, so now we have another revolute hinge. We can grab this one and move it in, that's G to grab, Z in the Z direction, now minus 0.5, and we move down minus 0.5 units, or minus 0.5 meters. So here we go. We have our clamp. We have our first revolute hinge, our second revolute hinge. But this one, when we created it, if we go in and look at the objects, it's actually itself is called revolute hinge 01, which is fine. That's the name of this over here. But it's associated with the clamp, and we want to actually associate it with the first revolute hinge. So we'll change this, and now it's associated with the first revolute hinge. So there we go. So we've got our clamp, we've got our first hinge, and we have our second hinge. Finally, we need to add a body. So we'll just do a body, and there we go, with a mass of 1. Now we're mostly good, except if we simulate this, there'll be no motion. So we'll need to start the motion by creating a reference frame at the clamp. And it will have a initial, as we saw over here, it will have a initial omega of 0.2. So let's go ahead and create that vector, and we'll have it rotate in the z-axis. So we'll create a vector. First, we'll create the one for the velocity, and that one will just be 0, 0, 0. And then we'll create one for the omega, which will 0.2. All right, and so there. Now we have both of our vectors, and we can go ahead and make our frame. So our frame will be of this first revolute hinge to the clamp. So we create our frame, reference frame, and this is our linear velocity, which is the 0, 0, 0. This is our angular velocity, which is 0, 0, 0.2. And let's just reconfirm that we're good with our reference frame. There. Okay, good. So now we have everything but gravity, but we have enough to be able to simulate. So let's take a look. We'll create a initial value problem, and then we'll run the simulation, and then we will animate. Okay. And there we go. So we have our revolute hinge, and it's starting in a reference frame at an omega of 0.2. So finally we need to add some gravity to the environment. So we'll do a plus environment gravity. This will be a unit drive. Currently it's at 0, 0, 0 vector, or we have that 0, 0.2. We don't want either of those. We want another vector. So we have to go create that. We'll make another vector here. This one will be 0, 0. There's several ways we can do it. We can scale it at 9.81 if we want there, and then we can make it in the minus z direction here. And we'll notice the name of this one, they just go sequentially. So now this one is 3 by 1.02. So if we go up here to gravity and edit that, we'll see that we can now select this. And if we want to reconfirm, we can just click that. We'll look at the vector, and sure it is 9.81 in the minus z direction. Okay, very good. So to conclude the demonstration, we'll just click on initial value, which will recreate our input file. We'll run the simulation, and then we can animate. Right? So let's animate, and we'll watch the pendulum go back and forth. Right? So there's a few other things, of course, we can look at. The first is we'll look at the input file. The input file is here, so let's edit it. Okay, we just created this, and you'll see how this compares to what we were modeling from our example. We have a reference frame, which is based on the clamp. We have 3 nodes: the clamp, the revolute hinge, and the second revolute hinge. We have our drives, and we have the unit drive is for gravity, and the meter drive is just for the simulation, for the output per time step. And then these are our elements, which we already had in that list. So then if we just look here, we have that one reference frame, which is 0. Well, because of the way it's oriented, the rotation in the global is 0.2. The add-on, Blender and NBDyn, takes care of all of the coordinate transformations for you. So it's global 0, 0.2, 0. Local, it was in that z direction. And we just do that because it's easier to, we've just created a graphic here which gives you the pyramid pointing in the z direction. So let's see, for that, when we go further into this, we've got our structural node, which is static at the clamp, and then we have that dynamic node for the body. And then, so we have the body, we have the clamp, we have the revolute hinge, and the second revolute hinge. And yeah, and then gravity. So those are those, and then I guess finally I just want to show, again, you can look at all of the plots. You can plot all the nodes. We could plot this node and see what it's doing. We can see X, Y, Z, and let's see here what it's doing. There you go. Right, so that's oscillating. We can also look at the moments. Let's see here. Oops, wait a minute. Oh, we can't plot gravity. It has nothing to plot for some reason. That was a bug. We'll fix that. All right, so we've got, let me see, px, py, pz. Let's see what this is. All right, there you go, px, py, pz. And then, there's more and more you can plot. You can plot for this revolute hinge. The second one, you can look at the output. We can look at its position. Those are the forces. Let's see what those look like. Okay, that's the z direction. And we could look at, I don't know. Look at the moments. Hinge, probably none because it's a hinge, right? Okay, that's enough. So that's the demo. The next two, if we get to those, will be more sophisticated and take more time. But I hope you find this helpful. All right, bye-bye.